Hello viewers, my name is Vikram and today I am going to have a session with you about the basics of physics. But before diving into lecture, I would like to have few words with you. The basic objective of delivering these lectures to help you understand better the concept and fundamentals of physics. From my perspective, physics is all about solving problems of this physical world by predicting the outcome of certain events, by using certain kind of measurements so that everyone objectively can predict the outcome of a certain event. So basically it is all about making prediction or have a smooth transaction of daily affairs around us as far as physical world is concerned. So to elaborate more on this concept, I would like to have an example with you. Basically, up to 10th, we encounter some kind of examples like problems in physics, like we have a certain condition, certain displacement, certain kind of force, and we are asked to calculate the work done in that particular event. So uh, we are actually required to predict the outcome, but objectively. So we have formulas and laws in place so to use or utilize them. So basically here physics is to develop certain kind of thinking, certain kind of laws, how these laws and formula works, so that we can predict in numericals the outcome, or in concept the outcome of a certain event. If certain situation are provided to you in a mathematical or in a physical form, you are you should be able to answer these outcomes objectively. So before starting this lecture, I would like to have uh, this conversation with you. Now let's start our today's lecture. Our first topic is unit. So first problem is to separate what is this physical quantity and what are not. So physical quantity in simple terms are those quantity which can be measured. To measure we require certain kind of instrument. That instrument or that for time being, let's suppose that instrument will act as a reference to measure any physical quantity. There are number of instrument and number of references depending on the quality of a physical quantity. Let's zoom further into it with the analogy I have for you. Let's say suppose we are required to answer the age of father, but we are given with a condition that the father age is twice the age of his son, and one more condition also given, and thrice the age of his daughter. So to determine the age of father, if I put, let's suppose son age is x, then I will have a outcome that father's age will be 2x. In similar way, let's say daughter's age is y, then father's age will be 3y. So uh, with this kind of with this reference, where I can have the father says in terms of this reference, that is the basic criteria or basic thought behind developing this concept that is called unit. Let's further explore it into our today's or in our physics, from physics perspective. Let's suppose you are required to, or you need to measure this length, and you have a reference that is universal for a community or for this whole world. This reference that is called 1 meter. Let's say this length is called 1 meter. It is a reference like the age of this age of sun. Now to measure this quantity, we require to pick this reference, not literally from here, but pick this reference and place it against this length and try to measure this length. And particularly in this example, the outcome of this measurement, that is this length is twice the length of this. Now if I name this reference as 1 meter, then twice will be 2 meters, and I can say that this length is 2 meter. So the name 2 meter comes from the reference from which I am measuring this length. In this similar fashion, in a for other community, let's suppose its name is community B, I have a different reference which is different from in term of amount, and name it 1 delta. And when to measure this length, I pick it up from here and put it against it, and the outcome is it comes out to be 4 times the length of this reference. Then I can say this is 4 delta. So basically, one thing here is to note that when the references changes, the when the reference changes, what would change? A number, that is numerical value, and unit, that is called reference or unit. So for a particular physical quantity, we can have different kind of units like meter, centimeter for length, kilometer, millimeter, micrometer. All these are our units. Based on what is considered as a reference, whether it is 1 meter or 1 centimeter, we will decide to put here the unit after the numerical value of a particular measurement for a particular physical quantity. So in totality, what is eligible to be a unit? It should have accessibility. I mean if we set for a community a standard that this will be called a 1 meter, then it should be accessible to everyone who want to or who is interested to measure or who is in a business of measuring lengths. So to make these replicas of this particular reference, we will distribute into the whole community so that it can have accessibility, or everyone have accessibility to these kind of references. Now second thing is acceptance. Everyone should accept that this will be called 1 meter, otherwise it will have no significance, or forgery is not actually allowed to this measuring terminology. Now second problem here is, once we have set a reference for whole community, the second problems comes into that is your numerical part. How to interchange one unit into other, and other unit into one unit into other. That would be asked in your exam, or you are in competitive exams. So now the second thing is, one problem is solved, we have a reference for, but there are number of physical quantity. How many references are required to denote or to identify every, or to measure each and every physical quantity? So a society, or after very much deep thought, it was understood that there requires certain kind of physical quantity. If we have references for them, then and particular references for them, then other quantity can be uh, determined or measured from the using these quantity in a particular manner or in a particular order. So now first of all, we define some fundamental physical quantities, and based on these physical quantity, we have some references that are called fundamental units. So like length, we consider length as a fundamental physical quantity, and for this we have a fundamental unit that is called meter. Similarly for time, we have second for SI, and similarly for mass, we have kilogram. For time being, you can remember these. Now by using these fundamental units, we can derive any kind of unit for a physical quantity. Like for a speed is a physical quantity. To determine its unit, we have distance over time, the formula, and by using the units of distance and unit of time, we can say that the unit of speed will be meter per second. This unit is called derived units. So that is the whole point, to limit the use, or to limit the number of references, so that life can be much more easier when we are dealing practically with it. So that is the basically whole scenario. to make these seven fundamental quantities has some kind of references. Let me have one example for you that is not required for your conceptual building, but still I am mentioning it. Like, suppose we are here to distribute or to determine what will be 1 kilogram. So a number of people all around the world sat on a table and they decide randomly, but a precise word, that a particular amount of a substance will be called 1 kilogram. Once they are agreed upon that substance, that this amount will be considered as 1 kilogram, they made replica of this uh, amount and distribute it distribute it globally, so that everyone has accessibility. So first they have acceptance that this will be 1 kilogram, this amount of substance will be 1 kilogram, and then they made replica of this, a, a huge number of replica of this, and distribute globally to everyone who is interested in measuring mass. In similar manner, in similar manner we can have a reference for length and a reference for time, and based on these references we made replica so that everyone has accessibility of these kind of instruments. Or now the last thing, but it is the most important, and so actually you required only this thing if you, but still I want you to have a clear cut understanding how does physics work. The last thing is, when we measure this quantity, this amount of this amount of physical quantity, the one thing is, this amount of physical quantity does not change. It doesn't depend on the reference from which we are measuring this quantity. So this quantity or this amount will remain same whatever unit we are using for whatever unit we are using to measure it. So we have a formula where this amount of substance will not remain change, will remain unchanged. This amount of substance or amount of physical quantity is equal to n into u. Here n is the numeric part or a number, and the u will denote the reference or unit. So every physical quantity will be written as a numerical part and a unit associated with it. Unit will signifies the reference, and this is the numerical value. Now the one thing that is the most important, suppose this length is this length L1 comes out at 2 meter and 4 delta. Here mathematically we can easily place them equal and solve solve some kind of issues, like how much delta will be in 1 meter, or how much uh, 1 meter, how much meters are present in 1 delta. These kind of questions will be asked, and we will see these kind of issues or these kind of problems in our later sessions. Thank you very much. If you like my effort, please do subscribe and share my channel. Thank you.